Hi everyone, welcome to another of our video chats. Today I'm joined by Professor Callum Roberts. Now Callum is a Professor of Marine Conservation in the Centre for Ecology and Conservation, which is based on our Penryn campus. His research focuses on threats to marine ecosystems and species and on finding the means to protect them. For the last few decades, his research has been making the case for stronger protection for marine life at both national and international levels. And that's led to 500,000 square kilometres of marine protection being established in the North Atlantic 10 years ago. Now, Callum's also an author and was Chief Scientific Advisor to the BBC's television series Blue Planet 2. But today we're actually going to talk a bit about blue carbon, which is a term that gets bandied around in the news at the moment. But you may or may not know what it actually is. So welcome, Callum. Thanks very much for joining me.
Pleasure to be here.
So I mentioned blue carbon. Can I just start by asking you to explain to people, what does that phrase actually mean?
One of the things that we know about our planet is that the carbon cycle is very important. And one of the unfortunate consequences of human activity is that we're altering the carbon cycle. We're releasing a lot of the greenhouse gas carbon dioxide into the atmosphere by burning fossil fuels. Now, some of that carbon dioxide is taken up by plants on land and is sequestered into their leaves and trunks and then is stored underground. And so areas like peat bogs are particularly important for storing carbon. Now, if you like, that's green carbon, it's land-based. But what there's been a lot of interest in recently is carbon that is taken up by creatures in the sea and then stored in marine habitats. And that's colloquially known as blue carbon.
Brilliant. Now, are there different ocean ecosystems that are better than others at absorbing carbon, or is it pretty much the same everywhere?
There definitely are some places that are better than others. And the very deep sea, thousands of meters down, is the kind of ultimate planetary sink for carbon. Once carbon settles on the deep sea bed, it's there for a very long time. And so in an ideal world, we would see lots of carbon being taken up and sequestered in the deep sea. But the most intensive sinks on a per unit area basis are actually coastal habitats, coastal wetlands like mangroves and seagrass beds and salt marshes. And what they're doing is they're taking up carbon, and just like a forest on land, they're storing it underground in underground biomass, the weight of organic material that those plants have produced. And so there are these thick soils underneath these ecosystems, which have a great deal of carbon within them. And we have calculations that suggest some of these ecosystems store 10 times more carbon than, for example, tropical rainforests do.
Wow. Wow. Now, what happens then if these kinds of environments are degraded? I mean, I'm assuming that means not only do they not absorb carbon, but they let carbon out. Is that the case?
That's exactly right. And in fact, some of these ecosystems are the most endangered of all marine habitats because they've been considered over the years to be fly-ridden swamps. And the best thing to do with a mangrove forest, for example, is to fill it over and build on top of it, or with a salt marsh, you might drain it, use it for agriculture and grazing land. And therefore, these habitats have been degraded. And when you cut down a mangrove forest, what that does is it removes the protection for the mud underneath, and then that mud begins to wash away. And so the carbon that's stored will be lost really quite easily after that habitat has been degraded, which is why it's so important to keep these habitats intact and healthy.
Yeah, now, I mean, you've worked on a lot of marine protected areas, like I mentioned in the intro. Are any of these kind of really key areas around the world, are they in marine protected areas? Or it sounds like there's an argument they should be if they're not?
Well, that's absolutely right. And fortunately, over the last 20 years or so, the value of these kinds of coastal habitats is being appreciated to a much greater extent. And we now realize that they're allies in the fight against climate change, not just because of the carbon that's being stored, but also because they protect coasts from rising sea levels. A mangrove forest, for example, is something that grows upwards as the sea level rises. And so, it's accumulating material underneath it. And that means that it's kind of continuously self-repairing natural breakwater. So there are plenty of reasons for wanting to keep these intact and protected, and therefore more and more of them are being incorporated into marine protected areas. One of my students looked at how mangrove forests in Central America had changed in area over the last 20 years or so. And she found that most of the mangrove forests there were now inside protected areas. And there had been very little loss of area in the last 20 years, which is very encouraging. It suggests that, we're kind of at a bit of a tipping point where the losses will begin to reverse, and we're going to begin to see increasing areas of mangroves being reestablished to promote their value as carbon sequestering habitats.
Brilliant. That sounds really positive. That's really good. Now, slightly different, but I mean, there's been some reports recently that basically said that we need to increase the rate of reduction of the amount of carbon we emit by 10 times in order to have any chance of meeting any Paris targets. And we also hear a lot about, carbon capture technologies. Elon Musk was tweeting about, giving away huge amounts of money for new technologies and stuff. So with that in mind, is there anything that can be done to actually help reduce emissions through marine environments?
Well, we love technological fixes, and indeed a technological fix is going to be very, very helpful in the fight to mitigate climate change and slow down the rate at which it's happening. But the very best form of carbon capture and storage that's ever been invented is photosynthesis. And so, those natural habitats are really the biggest asset in the fight against climate change. We need to be harnessing them to a greater and greater extent, both on land and in the sea. And these so-called nature-based solutions are a way of promoting two things at the same time. One is that we are losing wildlife and biodiversity across the planet very rapidly. And the other is that climate change is racing away. If we were to protect much, much bigger areas of the planet, and restore habitats across those areas where needed, then we would begin to start winning the fight on both fronts. We would be able to slow and reverse biodiversity loss, and we would be able to slow down the rate of climate change. So I think we need to deploy nature-based solutions at scale and very fast if we're going to meet the Paris Agreement targets. But it would be very helpful if there were also, alongside that, some technological solutions that could be deployed as well.
Yeah. Now, just one final question. Do you think the term blue carbon and these kinds of technologies are things that we're going to hear a lot more about as the impact of climate change becomes more obvious?
We undoubtedly are. And I think many countries are beginning to understand the need to use the natural abilities of the environment to sequester and store carbon in their accounts and their national accounting processes to meet the Paris Agreement targets. So I think now countries are in the process of inventorying their blue carbon stores and the stores on land. They're prioritizing areas for protection, partly based on those carbon values. So it's a conversation that's going to go on and on, I think.
Brilliant, thank you. Well, thanks so much for answering my questions today, Callum. Really appreciate you taking the time, and we'll be back with more video chats very soon.
Thank you.